All right, here's our first lesson, which is section 1-2 in the book. Now we're skipping 1-1. We'll come back to it later in the year when I think it makes a little more sense. But we're starting with section 1-2 on points, lines, and planes. Okay. By the end of this video, you should be able to describe points, lines, rays, segments, and planes. Also be able to describe how they're related. You should be able to correctly draw them and correctly name them. Okay. We are also covering two geometry standards, G.1 and G.1.1. Okay. Points, lines, and planes. Now, I would consider these like the building blocks of geometry. Okay. Every geometric shape, every idea we'll talk about can kind of be boiled down to being drawn with a point, a line, or a plane. Okay, now if you want to get theoretical, and we'll get a little theoretical in this class, these three terms don't actually have definitions as we'd call them in geometry. Okay, and the reason why is because we will use them to define everything else. So not everything has a definition. We'll define everything else in terms of points, lines, and planes, and so we'll leave these as undefined terms. Okay, a point is an exact location in space. Okay, I would think of it as like the very corner of a room or the corner of a book. It's an exact location. Okay, and specifically, a point has no length, no width, and no height, and so you couldn't actually you can't actually even see a true point, and you can identify a location, but it's so small that you can't actually even see it. Okay, a point is named by a capital letter. Okay, point P using a capital P is the name of the letter. Okay, the picture would be this right here is point P. Okay, and I've labeled that point using a capital P. Okay, that's a point. Now, a line is a one-dimensional object. If you want to jump back and talk about a point is actually a zero-dimensional object. Okay, so lines are a one-dimensional object that have only length to them. Okay, lines continue on forever in both directions. That's why this line has arrows on both sides. Okay, because a line has no width or height, you actually couldn't see a line either. Okay, think of it like where the wall and the ceiling meet. You can measure the length, but since there's no width to it, you couldn't actually see it. A line is defined by 2 points. And you can name that point, that line, I'm sorry, using any 2 points on that line. Okay? Or sometimes a line is given a name using a lowercase cursive letter. Okay? So this line down here, we can name it AB. Again, A and B are both capital letters because they're points. Or BA. And above those lines, those letters, we have a line with 2 arrows. Okay, meaning it goes on forever in both directions. Or if it happens to be given a name like lowercase l, we'll call it line L. Okay, a ray is part of a line. Okay, it's a 2-dimensional object that has a starting point but no ending point, so it kind of goes on forever in one direction. Okay, kind of like a ray of sun starts at the sun and then goes on forever in the same direction. Okay, a ray is also defined by 2 points, and it's named using the end point and then any point that's on the ray. So this ray will start at A and then go in the direction of B forever. Okay, now this left-hand letter is always the endpoint. Okay, the right letter is any point on the ray. Okay, so if this point was C, I could call this ray AB or ray AC. Okay, and also notice that above AB, I have a line with only one arrow, and it's always going to be pointing to the right. Okay, opposite rays are two rays that share the same endpoint and form a straight line. Okay, you label them the same way you name a ray. So CA and CB are both examples of rays. Okay, a line segment, or sometimes just commonly called a segment, is a two-dimensional object that has a starting point and an ending point. So it starts somewhere and it ends somewhere. A line segment can be measured with an exact length if you're given a ruler or some kind of a metric. It's also defined by 2 points, and it's named using the two endpoints. Okay, so either this segment is segment AB or segment BA, either one is fine. And also notice that above the letters, it's a line with no arrows because it doesn't go on forever in either direction. Okay, now lines can do various things. They can intersect, they can not intersect, so that there's ways that lines are related to each other. Okay, now here's a question that I wish we could discuss, but is it possible for lines to not intersect and not be parallel? Okay, if you think about it for a second, um, maybe you think the answer is no, but if you think three-dimensionally, the answer is yes. Okay, now this is a three-dimensional box, and if you think about, for example, this front left edge, okay, and then if you think about over here this line, they actually will, they're not parallel because they're not really in the same direction, but if you kept drawing them forever, they actually wouldn't intersect. And it's hard for me to draw that on my two-dimensional board. But if you look around your room and you pick some of the edges, it's possible to find two that if you drew them on forever, they still wouldn't intersect, but they're not going in the same direction. Okay, these lines are called skew lines. Okay, lines that are not parallel and don't intersect. Okay, so kind of in summary, lines, they can intersect or they could be parallel. Um, if they intersect, they could be perpendicular, which we'll come back and talk a lot more about this year, but basically perpendicular means they intersect at 90 degrees. Um, okay, or they could be skew, meaning they're not parallel and they don't intersect. Okay, a plane. A plane is a flat surface that has no length, so I'm sorry, that has length and width, but no height. Okay, you can think of a plane as in kind of like a piece of paper. It's infinitely thin, and it goes on forever in all directions. Okay, you can see a plane, unlike a line or a point, but you have to view it from a certain angle, like from the top. In this picture, if you see it from the top, you can see the plane. But if you kind of got down level with it, it would kind of disappear because it's infinitely thin. Okay, it goes on in all directions. It's defined by 3 points. Okay, um, and you can name a plane using any 3 points in the plane. Okay, for example, the plane down here at the bottom right is plane ABC, plane BCA, plane CAB. The order doesn't really matter, just any 3 points in that plane. Or sometimes it's given a name of an uppercase cursive letter. Now, with computers, it's kind of hard for us to draw or write an uppercase cursive letter, but if it's by hand, it's easier to draw an uppercase cursive letter, and that's how we give a plane a name. So plane P is the name. So either using that one letter name, or using 3 points in the plane. Okay, now planes can intersect. Okay, for example, an X-wing fighter from Star Wars has wings that intersect. So these wings right here intersect. Okay. Also, a book, the binding and its front cover intersect. Okay, so this binding and the front cover intersect right along that edge. Okay. Planes can also be perpendicular, so they intersect at 90 degrees. Okay, for example, a TIE fighter from Star Wars has wings that are parallel. So this and this are parallel. Sorry, are parallel. And a book's front and back cover are also parallel. Okay, so in summary, planes can intersect. They can be parallel. If they intersect, they can be perpendicular. Okay, a few other definitions to kind of throw at you because they're related to all these ideas. Collinear points are points that are on the same line. So linear means line, and collinear means same line. And so collinear points are points that are on the same line. Okay, so for example, points A, B, C, and D are all collinear because they're on the same line. Okay, coplanar, points and lines and objects that are in the same plane are called coplanar. Okay. All right. The last big idea we're talking about in this section is a postulate or an axiom. Okay. It's an accepted statement of fact. They should be pretty self-evident. They should make sense without you having to really kind of explain them too much. But these are also kind of, on a theoretical standpoint, kind of the building blocks of geometry as well. Okay. Here are a few examples. Through any 2 points, there's exactly one line, which means if you pick any 2 points in space, you can draw exactly one line through them. Okay. Another example, postulate 1-2. If 2 distinct lines intersect, then they intersect at exactly 1 point. Okay, because lines are straight. If they intersect, they only intersect once. They can't intersect again somewhere else. Okay. Another postulate is if 2 distinct planes intersect, then they intersect in exactly one line. Okay. And the last postulate we'll talk about today is through any 3 non-collinear points, there's exactly one plane. Okay, so if you pick any 3 points in space, you can draw a plane through them, and there's only one of those planes. Okay, now I don't mean to go get too theoretical, but those are just some examples of postulates or axioms. Okay, they're statements that should make sense. You can draw pictures, and usually it makes sense. Okay, so in summary for this lesson, 1-2, about the building blocks of geometry, points, lines, planes, is what we'll use to define everything else in this class. Okay, you should also be familiar with the ideas of rays, of segments. We also kind of briefly mentioned collinear points and coplanar objects. Okay, hopefully you can describe how they're related, if they intersect, if they don't intersect. Hopefully you can correctly draw these objects and also correctly name them.